And again, I'd like to welcome you to today's TechNet webcast, Windows Hang and Crash Dump Analysis. We're coming to you live from TechEd 2006 in Boston. Today's presenter is Mark Rusnovich. He's the Chief Software Architect at Winternals Software. And we're going to pause for just a moment while Mark takes the stage live in Boston. So please stand by.
Not only the people in the room, but this is being live webcast. So how about everybody in the room welcome the people that are on the web listening in. I also want to thank, before we start, Vince Orgavan, who's the head of the Windows Online Crash Analysis team, and Silvio, who's on the team with him, who are serving as the subject matter experts for the web audience. They're answering questions live as a favor for me. I really appreciate them doing that. And I also, because this is webcast, I want to apologize for a little bit of the awkwardness that you're going to see, because this is a very demo-intensive talk, and unfortunately, live meeting won't install on 64-bit Windows. So I'm actually going to have to TS into my machine to show you the demos, and I'm going to have to switch back and forth between live meeting and the terminal server console. How many people have seen me present already this week at TechEd? How many people haven't? Let's see that. Okay. Welcome to the new people, and welcome back to the people that have seen me before. Just briefly, a little bit about myself. I'm Chief Software Architect and co-founder of Winternals Software, a company that specializes in Windows infrastructure products, and co-author of Microsoft's official book on the internals of Windows called Windows Internals with David Solomon. Also, a lot of you probably know me from SysInternals. This is the outline of what we're going to cover today. I'm going to first talk about crash dumps and the tools that you need to use to analyze crashes. Then I'm going to talk about a few basic concepts that make the job of both understanding crashes and analyzing them easier, and those include IRQLs and stacks. Then we're going to jump right into looking at crash dumps, starting with a very easy to analyze crash dump, move on to unanalyzable crashes, which I'll explain the reasoning behind that term as we go along, show you some examples of transforming those unanalyzable crashes into ones that you can analyze, and then I'll conclude with manual analysis, where the automated analysis doesn't help you. How many people in here have analyzed a crash dump before? Okay, keep your hands up. How many people have done that successfully? Okay. Well, that's a pretty good number of people. So what are you doing here? Actually, what are you doing? What is anybody doing here? Windows doesn't crash anymore, does it? In fact, I only got this talk into TechEd because I called it how you used to troubleshoot those crashes that used to happen on older versions of Windows. And then I changed it at the last second. It was too late for them to pull it. So many systems administrators, unfortunately, don't analyze crashes because they don't know that they could do it. They think it's too hard. They think even if they take all the time to learn how to do it, that it's not going to tell them anything anyway, so they don't even bother. What you're going to see here in the next 75 minutes or so is that basic crash dump analysis is actually really, really easy. It's so easy, it's just like point and click and you're done. Even if only a handful or some small percentage of the crashes you look at actually reveal an answer, and you'll understand why some crashes just won't reveal an answer, it's still worth taking a few minutes to analyze crashes. I want to do a level set here, though. I'm not going to make you crash dump analysis experts in 75 minutes. In fact, it would take weeks and weeks and months of eating, living, breathing crash dumps, like the critical problem resolution engineers at Microsoft PSS, who are dedicated, focused on analyzing Windows crashes. Those guys are so good that you can give them a dump of physical memory, and they'll be able to look at it, and by looking at the bytes, say, oh, there's a pool header right there, and there's an IRP right there, and following that, there's a file object, and figure out how to traverse stacks without the help of the debugger. That requires intense knowledge of x86, x64, and even Itanium assembly language for those guys. It requires understanding all sorts of different calling conventions that Microsoft applications and third-party drivers use to call each other so that they can analyze the stack. And it also means lots of experience working with Windows internals to understand what these objects are, how they connect together, and recognize their footprints when they're looking at memory dumps. So I'm not going to be able to take you there, but I'm going to take you far beyond, hopefully, what the basic sysadmin that might know that you can analyze crashes is able to do. I'm going to show you a couple of tricks that will transform those unanalyzable crashes, those ones that they aren't able to analyze, into ones that you get an answer out of. First, how many people have ever seen a crash out in the public someplace? Windows blue screen in some public place, right? Probably, I'm guessing, airports, right? ATM machines. I've got to actually keep a collection of crashes, crash pictures, that reminders, that I'd like to share with you. Starting with this one. This is a British Telecom telephone that's blue screen. This is an ATM machine at San Francisco International Airport. This one is kind of interesting because Dave and I teach a Windows internals class. We taught a public seminar in San Francisco. And right after the class, the last topic is crash analysis. The attendee goes to the airport and boom, presented with a crash. This one's at a Barcelona train station vending machine, ticket vending machine, and somebody's obviously gotten really upset with this blue screen, plastered red stickers all over the box. It's a little Christmas cheer over here at the airport, over on this monitor. And airports are, like I said, a frequent place where you see these things. Here's at a baggage claim. Here's at another baggage claim at Zurich International Airport, and this one shows Microsoft's dedication to their international customers. If you look at the text at the bottom of the screen, that useless message about contacting somebody else to help you, it's been translated in German so that they feel comfortable with that. This is CompuSA's bestseller, which I just don't get. And for those of you that have seen Dave Solomon and I speak together, he was here earlier this week co-presenting with me. This is him going on personal vacation at LaGuardia's Continental check-in counter, and he's got this smug expression on his face. His wife took this picture of him because he'd analyzed the reason for the crash and turned to the people behind him and is explaining it to them. Not that I think that they really cared. This is probably the largest blue screen ever. It's on one of the largest hotels in the world. Anybody recognize that? When I zoom out, you might. Las Vegas' MGM Grand Hotel. And if that's the largest, this is probably the most public. This is a famous intersection in New York City, Times Square. Brian Valentine, who's the head of Windows development, happened to be walking through the intersection on the day this appeared, which I think was some really bad timing on the part of seeing the blue screen. He obviously made him very upset. This is just a block away at the Times Square subway station. It's really annoying that they haven't tilted the screen so that I can fully read the text and figure out what happened. And this is Iraq's former information minister. He did such a good job over there that they've hired him. This is a shirt that's blue screen. Actually, you can go buy this shirt online at a company called Errorwear.com, ERRORWEAR.com. And I supplied them that image for the shirt, and in return, they gave me a complimentary copy of that T-shirt. And I just want to give you a word of advice. If you're ever on Microsoft's campus and you're wearing this shirt, stay away from Building 26, which is the NT Development Building. Especially stay away from Brian Valentine's office, especially if it's the first time you meet him. And I'll just leave it at that. And this is what most systems administrators end up doing after they can't figure out what the problem is. So with that, let's return to the slide deck. Here's a little gyration I have to go through. See if I can get this to work. There we go. So why does Windows crash? A lot of you probably have thought at one point or another, hey, why doesn't it have like a 3 strikes and you're outlaw? Well, the Windows only crashes when something in kernel mode goes wrong. User mode code cannot, because of the protection mechanisms built into the operating system, cause a problem that results in the operating system turning over and bellying up. So something's gone wrong in kernel mode for there to be a crash. Kernel mode is a trusted environment in the Windows operating system, just like it is in most operating systems. Any drivers and the operating system kernel code itself can access basically anything they want to. They can access data buffers that are sitting in a file system cache about to go out to the disk. They can access even user mode code if they want to and data. And when a component detects that something's wrong, it's got one primary responsibility, and that is the preservation of your data. Because what might have happened already is corruption of buffers that belong to SQL Server data store or your PowerPoint presentation file. And if the system were to say, hey, you know what, we're just going to ignore that one. Let's see if we run into another problem before we give up on this thing.